Assalamualaikum and hi everyone. A very good day to all my dear students. I'm Cikgu Atika from SMJ Kechua, Kota Baru, Kelantan. Today we are going to discuss on essay question Fizik STPM 960/3 based on Jicana Kelantan module on section C, question number 20. Dear students, why did I choose question number 20? The question are in accordance to the STPM new syllabus for Physics 960 and it evaluates candidates' knowledge of physics in area of fundamentals, application and the higher order thinking skill. I hope by the end of the discussion, students are able to make a good choice in section C. This is because the probability for question 20 is higher to come out in STPM paper based on topic chapter 24 quantum physics and chapter 25 nuclear physics. And students, remember, less formula is required in this question in terms of calculation. So that's a best choice for you to gain more marks. Okay, let's see in chapter 25 nuclear physics what we are going to learn. So there are three subtopics in this chapter. Subtopic number 1, 25.1 nucleus, 25.2 radioactivity, 25.3 nuclear reaction. So what is the learning objective that we should learn in this chapter? So by the end of the lessons, students should be able to explain mass defect and binding energy. Use the formula for mass energy equivalent E equal to mc square or Einstein formula. State and use the exponential law dn over dt equal to negative lambda n for radioactive decay. Relate the occurrence of fission against nuclear number. Explain the condition for a chain reaction to occur. And the last one, describe a controlled fission process in a reactor. Dear students, summary for chapter 25. Radioactive decay is the process by which alpha, beta and gamma ray and is stochastic or random and spontaneous. Random means that every atom have the same probability to decay. Spontaneous means that the process is unpredictable. It is not depend on any physical factor such as temperature and mass. So dear student, you can see in the screen, heavy unstable elements such as uranium decay to produce alpha particles, gamma ray and proton, beta particle and also neutron. And this process occur because of the bombardment of energetic particle. You can see on the slide. So how when the neutron is bombarded into the uranium-235, unstable nucleus and it decay, become krypton and barium and also energy is released during the process. So we can make a recap. Nuclear fission is nuclear reaction initiated by the bombardment of the nucleus using alpha particles or proton from particle accelerators were limited to small nuclei. Alpha particles and proton are positively charged and experience increasing repulsive Coulomb forces as they approach the positively charged nucleus. A large nucleus produces a strong repulsive force. So remember, neutrons are not charged and do not experience the potential barrier of the nucleus as shown in the figure below. So, let us identify the best way to cope and master the question. So, we should focus what the question needs from us. So, I have listed, there are 4 steps here that you can follow. Step number 1, clarify the physics concept and the key point relate to the question. Step 2, identify the subject and the subtopic related. Step 3, list down the related formula. And step 4, write the units. Remember, my dear students, most of students lost mark during the exam because of the unit. So please take notes. So let's start with the question number 20A. Radioactivity is said to a random and spontaneous process. What is meant by number 1, random, and spontaneous in this context? Write an equation for the rate of decay of a pure radioactive source in terms of the number of radioactive nuclei present, and show how this is consistent with the random nature of the process. And this question allocate 5 marks. So if you can see on the slide, my dear, I have highlighted there are 5 key points that we have to concern. Okay, let's see the sample of students' answer. So, based on the answer, there are 5 marks given to the students. So remember, every single tick considered as 1 mark for 1 point. Okay, let's see the answer scheme. So random, at any instance, the chance of a radioactive atom decaying is the same for all radioactive atoms. Spontaneous, when a particular radioactive atom which decay cannot be predicted or controlled by physical condition. So you can compare the answer from the students with the answer scheme. So we can see the students are able to give the same physics concept to the question. And remember, my dear student, you can give answer or explanation in whatever pattern, but the physics concept must be clear. Okay, next question is about equation for the rate of decay. So another 3 marks required for the student to state about dn over n equal to dt equal to constant, which is actually this equation mention Decay's law. So what is meant by Decay's law? So Decay's law is rate of decay is directly proportional to the number of radioactive present in the sample. So these 3 equations will give us 3 marks. So let's see another question, question number 20b. State the third product, including its number, in the following nuclear fission reaction. What is the role played by the said product in the operation of a nuclear reactor? This question requires 2 marks. So you remember using step 1, identify the physics concept. So from the question, we know that nuclear fission is defined as an unstable atom split into 2 or more smaller pieces that are more stable and release energy in the process. Let's see students' answer. So, these students are able to relate the physics concept very well by calculating the mass number S and atomic number Y, which give the value of neutron. So, let's see. Let's compare with the answer scheme. So, the answer scheme, the third product is 3 neutron. And why this 3 neutron is very important? To ensure that the nuclear fission of uranium-235 will be continued. So this process also release extra neutrons, which can then split additional atoms, resulting in a chain reaction that release a lot of energy. So my dear student, let's move to question number 20C1. So again, a Swiss nuclear reactor of 20% efficiency can produce maximum power 1.00 megawatt. The nuclear fuel used is uranium-235, and the nuclear reaction that occur in the reactor can be assumed to be represented by the full equation of B2. Calculate the energy released by each uranium-235 atom which undergoes the fission, and this question allocates 3 marks. So again, to answer this question using step 1, identify the physics concept. So from the question, you can see on the screen, I have highlighted the informations given. So let's see the sample answer. So try to identify why the student's answer was wrong. So for the first part, E equal to mc square. There's 1 mark given to the students. But for the substitution, there's no marks given. And final answer, there's no marks given. So let's discuss in answer scheme. So you can see in the answer scheme, student forgot to calculate the mass of neutron. That's why this student didn't get marks for the second substitution, for the second marks. But the first marks given to the students, once students apply, E equal to MC square. And the final answer with the correct unit, but the student also lost this mark because the wrong substitution that make it by the student just now. So my dear student, to master the concept, always use step 3. List down the related formula and remember the mark is given for formula in marking scheme. Okay, next we see last question. Question number C2. Calculate the number of uranium-235 used by the reactor in a period of 12 hours if the reactor is operating with maximum power, and this question allocate 2 marks. And remember, as usual, identify the key point. We can see students might do mistake if they did not highlight the key points. This is quantitative question required to apply the formula. So dear students, let's see the sample of student answer. So mark number 1, their formula stated E equal to PT. So the 1 mark is given to the student. But for the second one is wrong substitution, and the third one also wrong final answer. Okay, let's compare with the answer scheme. So the energy produced is actually 1 hour. Then you can see, but the student didn't calculate. But the E equal to PT is given by the student. Okay, next about nuclear atom also, the student wrongly calculate. That's why there's no marks given to the student for this question. Okay, my dear students, next we move on to last question. Question number 20, C3. Calculate the minimum mass of uranium-235 required if the reactor is set to operate for 180 days a year for a period of 10 years. And this question allocates 3 marks. Dear students, again, I love to remind you, don't forget to highlight the key point and answer what question asks you only. Okay, let's see the sample of students' answer. The formula is given by the student, E equal to PT. Okay, and I'm giving all the correct for the second mark and for the third mark. But I wrote there, BOD. So what is meant by BOD? Benefit of demand. It means that this student gave the wrong calculation, but the physics concept is there. Remember, I told you in our earlier discussion just now, in physics, we are really concerned on physics concept. The physics concept is our main priority in STPM. Okay, let's see the answer scheme. So the total number of atoms required in 10 years. So the student used wrong value, but the physics concept is correct. So that's why all the substitution from the first mark, second mark, and the third mark is correct. Okay, my dear student. We come until the end of the session. Last but not least, I hope every one of you can achieve the successful criteria for today, which is actually making a good choice in section C. All the best. Thank you.